Now let's take a look at solving equations with radicals. So let's look at solving equations with the radical expressions that we've been working with in this chapter, for example, right? Such as square roots, cube roots, and what have you. Right? We'll start with a real simple example on that. Now, remember, let's recall it from previous math class. The key concept is to isolate the radical and then take it to a certain power to get rid of the radical and finish solving the problem. So here's what I mean by that. Let's suppose we have something like square root of x. Let's say minus 5 is equal to 11, for example, right? Well, so step one, so we solved this equation in the past, right? It's just a simple square root equation. But to solve this, we're going to first isolate the square root, right? So let's go and add 5 to both sides, since that's not part of the radical here, right? This is outside the radical, just add it to the other side here. So we get square root of x is equal to what, 16, right? And then to get rid of square root, we simply take it to the second power. So raise both sides to the second degree, or to second power, right, to the power of 2. So square both sides, basically, right? Because squaring and square rooting will get rid of each other, right? They cancel each other out. So you have x left over equal to what? Well, just punch it down to the calculator. 16 squared, 256, all right? So that will be the solution. So again, simply isolate the radical and then square both sides in this case to get rid of the square root. What about a cube root equation? Let's try this one. Let's take a look at something like the cube root of x minus 8, all right, plus 2 is equal to, let's make it equal to 7, for example, all right? Okay, so let's go ahead and, again, isolate the cube root. So let's subtract 2 to both sides to do that. Okay, so again, 2 is not part of the radical here, right? So subtract it out. So we're going to get cube root of x minus 8, all right, is equal to 5. And then, how do I get rid of this cube root? Well, here, to get rid of square root, we have to square both sides. So to get rid of cube root, we're going to take it to what? The third power. So the key concept here is what? To get rid of a radical, you simply take both sides to the same power as the root index. Root index is 3 for cube root. Take it to the third power to get rid of the cube root. So we're going to have x minus 8 equal to what? 5 cubed is 125, all right? And then we can just add 8 to both sides to finish the problem. All right, no big deal. So x will be equal to what? 133 in that situation. All right. Certainly, we can plug it back in to check our answers, right? If I plug 133 back in, what do I get? Well, 133, just doing our heads or by calculator, but just plug in the 133 for x real quickly here. You see that we'll see that 133 minus 8 is what? 125. The cube root is 5, and 5 plus 2 is indeed 7. Right? So no big deal. Again, the theme is what? Isolate the radical and then take both sides to the same power as the root index to get rid of the radical. All right? Not too bad at all. Let's try another one here. Let's take a look at this one here. How about the square root? Let's go back to square root here. How about square root of 4x plus 5 minus 12? Okay, so the minus 12 is outside of the square root in this case, right, equal to, let's say, negative 5. All right? Again, how do I get rid of the negative 12? We'll add 12 to both sides. Okay, no big deal there. So we're going to get square root of 4x plus 5, all right, equal to what? Positive 7. Now we can what? Square both sides. Take both sides to the second power there. All right, and that will get rid of the square root against square root, and square and get cancels each other off, right? So you get 4x plus 5 is equal to what? 49, 7 squared, right? So easy equation to solve then, right? Subtract the 5 over, obviously. Okay, running out of space, but you see that 4x, let me continue here, is equal to what? 44, or x is equal to 11. If I divided both sides by 4 here to solve for x. Right? So hopefully, again, not too bad. Again, just plug it back in. So I plug 11 back in. What's 4 times 11? 44, right? Plus 5 is what? 49. What's root 49? Root 49 is what? 7. So 7 minus 12 is indeed negative 5 if you just sort of check it in your head or by calculator, if you will. All right? Let's try another one. So let me go and clear out the screen. Well, let's take a look at, this time let's try the fourth root equation. Fourth root of x minus 8 plus let's make it plus 4 is equal to, let's say, 7. All right? Fourth root equation here, right? So the root index is 4 in this case, right? So again, just simply subtract 4 on both sides, as we've done in the past. All right? So we're going to get what? Fourth root of x minus 8 is equal to 3. Now, how do you get rid of fourth root? Well, you take it to the what? Same power as the root index. So take it to the fourth power to get rid of the fourth root. So that takes care of that radical. So we get x minus 8 equal to what? 3 to the 4th on the calculator is what? 3 times 3 times 3 times 3. Or how about 81 then, right? So just add 8 over to finish the problem. So clearly x is equal to 80 what? 89 in that situation. All right, so hopefully not too bad. Again, the key concept: what? Isolate the radical, and then what? Take it to the same power as the root index to get rid of it, and then finish solving the equation. So not too hard at all, as you can see here. All right, let's go ahead and, but we have to be a little bit more careful with these problems here. Let's take a look at. Here's what I mean by that. Let's take a look at this problem here. Look at one that's a little bit more challenging to solve. Now let's try this one. How about x plus 3? Let's do another square root equation. How about go back to the square root equation? Square root of what? X plus 2. Okay, a little more tricky here. All right. Okay, so equal to what? Equal to 8. Let's say. All right. So let's look at this one. This one's tricky because of this x out here, but that's okay. The concept's still the same. You're still going to what? Isolate the radical and then square both sides in this case, since this is square root, right, to get rid of it. So let's go subtract the x on both sides because you want to get the radical by itself. All right, pretty tricky there, but no big deal. You get 3 square root of x plus 2 equal to 8 minus x, right? Now what happens? Well, you can now square both sides. So but this one is a little more tricky, so let me go and square both sides more carefully, especially this left-hand side, and actually both, the right-hand side as well. Because what is the left-hand side squared? Well, 3 has to be squared as well, right? So 3 squared is what? 9. 3 squared. What about radical x plus 2 squared? Well, again, that will get rid of the radical, right? The square. So what's left is x plus 2, but you got to put that in parentheses because it's being multiplied to the 3 squared, or the 9 in this case. So very important, you have parentheses around the x plus 2 after you get rid of the radical. That's equal to what? Well, again, use that formula we had from a previous section, right? This is a minus b quantity squared. And that formula says what? A squared. So here's my a, right? This is my a. This is my b, right? So my a is going to be 64. So a squared is 64, right? Minus 2ab. So minus what? A times b is what? 8x. Double it. So minus 16x. So make sure you review that formula a little bit to help you solve these, to help you square this out, to help you save some time. Otherwise, just write it twice and do the FOIL method. But it's better if you know the formula. So what's b squared? Plus b squared, a squared minus 2ab plus b squared. So plus what? X squared. All right, no big deal. All right, now no more radicals. Just simply solve this equation essentially, right? So let's go ahead and do that then. Let's go ahead and get the now this has an x squared in it, so we're going to solve this by factoring. So keep that in mind. But let's go ahead and distribute the 9 first of all to get 9x plus what? 18. All right, equal to, let me rewrite this in the proper order. How about x squared first, minus 16x second, and plus 64 last. All right, so since I want to solve this by factoring, let's zero out, and my x squared terms on the right side, let's zero out the left side by subtracting 9x, and by subtracting 18, if you don't mind me doing that in one shot. So minus 9x minus 18. All right, so that's 0 now on the left, but on the right, that's going to be x squared, what, minus 25x, right? Negative 16x minus 9x. Negative 16x minus 9x is negative 25x. And 64 minus 18 is going to be what? 46, I believe, right? All right, just punch on the calculator if need be. But anyways, we can now solve this by factoring here. So let's factor that. That's going to be what? X, what two numbers? Well, that's not too hard. Multiply 46 add up to negative 25. That's negative 23 and negative 2. So x minus 23, all right? And x minus what? 2, because that will multiply the positive 46, add up to negative 25. But again, if I set these factors to 0, I get x equal to what? 2 answers here. So here I have 2 answers here, right? 23, positive 23, and what? Positive 2. All right? But go back to the original equation. Let me recopy it down here. The original equation was what? Was x plus 3 radical x plus 2 equal to 8. All right, you got these two answers of x. Let's plug them in to check. Let's start with the 23. So let's start with x equal to 23. Let me continue since I'm running out of space here. Let me separate these two problems here so you can see it more clearly. But yeah, so x equal to 23. Let's check that first. Let's plug it in. So 23, I'm plugging in 23 for x, right? Plus 3 square root of 23 plus 2. Right? This is on the left-hand side, right? Is that equal to 8? Well, you're going to see that this is not going to be equal to 8 because look at this 23 is already bigger than 8, right? And certainly if you add a number to it, it's going to even be bigger, right? So 23 and 2 is 25, right? 23 plus 3 times 5, right? Root 25 is 5, right? So 23, again, I'm just working it out for you, but you see that 3 and 5 is 15. This is clearly not equal to 8. This is 38, right? Which is not equal to 8. So this answer right here, this 23 is not valid. So make sure you check your answers a little bit on these types of problems, right? You can do it by calculator. You don't have to show all the work here, right? But I'm just trying to show you that 23 for x, if I plug it back into the original equation, is not going to be a valid answer. What about 2? Well, let's check this 2 right here. Let's plug it in. So x equal to 2 here. Let's plug it in. So 2 plus 3 square root of 2 plus 2 on the left-hand side. So 2 plus 3, don't add the 2 and 3 now. That'll be violating the order of operations, right? Do the root first. So 2 plus 2 is 4, so root 4. And that's equal to what? 2 plus 3. Again, don't add the 2 and 3 yet because you can't. Because that'll be, again, we have to multiply before adding, right? So what's root 4? Root 4 is what? 2. Alright? So this is 2 plus 6, which is indeed equal to 8. Check. So this is a valid solution too. So 2 is my solution here. So x equal to 2 is the only solution we have for this problem here. So be a little bit more careful when you solve these equations, right? The theme is the same. Isolate the radical, raise both sides to the correct power, to the same as the root index. In this case, just square both sides, right? To get rid of the radical and finish solving the equation that's left over. In this case, we have a polynomial equation which we have to solve by factoring. But then we got two answers. We have to check both answers, make sure they are both valid. In this case, 23 is not, as you can see the work down here, right? But 2 is valid, as you can see here. So just 2 is the answer. Eliminate the 23, the extra answer. All right? Let's go ahead and try another one here. Let me go and clear out the screen. Let's try one with two radicals, right? A little bit more tricky here. What if I have 2 square roots here to deal with? Let's make it 2 radicals, make them square roots for simplicity's sake. Let's try square root of x plus 5, all right, plus the square root of x is equal to 5. All right? Now, with 2 square roots, it becomes more tricky because here I cannot simply square both sides. Because if I square both sides, I'm going to use that a plus b squared formula, right? I need to put parentheses around the whole left side. And I need to use the a and the b, a plus b squared formula, and that which complicates matters. So the best way to solve this is to isolate one of the radicals and then square both sides. In this case, I'm going to isolate the first one since this one looks more complicated because it has 2 terms. This one only has 1 term. So let me just bring this root x on the other side. How do I do that? Just subtract it out. Subtract out the root x on both sides. All right, no big deal. So you get root x plus 5. So this problem's a little bit trickier because of the 2 radicals, right? But root x plus 5 is equal to what? 5 minus radical x. All right, 5 minus root x. Now I can square both sides to get rid of the first radical here on the left. But be careful on the right. I need to put parentheses around the entire right side and put a square right there. All right, so that takes care of the root right there. So I get x plus 5, which is what we're looking for here to get rid of this first square root, right? But here again, I need to use that formula we had earlier. This is a, and this is my b, right? So use that formula, a squared minus 2ab plus b squared. So again, if you want me to show some work, I'll do that here. Take a look at 5 minus root x on the side here. All right. So my a is 5, and my b is root x. All right. So a squared is what? 25. All right. What's a times b? A times b is 5 radical x, right? But I have to double it. So that'll be what? 10 radical x. We double the coefficient only. Let's recall that. So minus 10 root x. All right. And then b squared. Square this b, square root x, you simply get what? X. So plus x. In other words, this thing squared on the right side is this result right here. So again, you might want to show the work on the side if you need to, using that perfect square formula, or write it twice and FOIL out, but hopefully you can use the formula. All right. Anyway, so on the right side we get what? We get these three terms. 25 minus 10 radical x plus x. Now we still have a radical remaining, so just isolate the remaining radical and then that should do the trick. Right? Let's go ahead and bring the 25 and the x on the left side then. Let's subtract out the 25. Alright, that gets rid of that on the right side. Let me at the same time subtract out the x if you don't mind, because that will get rid of x actually on both sides, which is good. So I just have negative what? Negative 20 equal to what? Negative 10 radical x. Can we see that? Now, before we square both sides here, let's notice that 20 can be divided by what? 10, right? Let's divide that out. Let's divide out the negative 10 on both sides. Divide by negative 10 on both sides to isolate this root x. So this is going to be positive, right? Positive 2 equal to root x. So now, as you can see, if I square both sides to finish this problem, then you see the final answer being what? Again, that gets rid of the square root. So x, let me put it back on the left here. 2 squared is simply 4. That's the solution. Again, check your answer. Plug the 4 back in. 4 plus 5 is 9. Root 9 is what? 3. All right? If I plug it back in, what's root 4? 2. So 3 plus 2 is indeed 5. All right? So you can certainly check your answers very quickly if you just plug it back in by calculator, or just do it in your head if you will. All right, no big deal. But with two radicals, you do have to do a little more work in terms of isolating the one of the radicals, and then squaring both sides. End up squaring both sides two times when you do that. All right, so a little bit tricky here in that situation here. All right, let's go ahead and try another one. All right, let me go ahead and clear out the screen. Let's go ahead and try another one. Let's take a look at this problem right here. How about the square root of x minus 1 minus the square root of x plus 2 is equal to, 2 equal to 3. All right, 3 right there. Sketchpad's acting up. Sorry, guys. Right, but let's say the same theme. In this case, take your pick on which one you want to isolate, because they both have two terms inside. Right, but again, I'm gonna want to keep everything positive, so I'm gonna add this thing to both sides if you don't mind here. So I'm gonna add root x plus 2 to both sides to get rid of it on the left side. 2 there. Sorry about that. So that takes care of that. So I have square root of x minus 1 on the left side equal to 3 plus radical x plus 2 on the right side. Again, I need to square both sides to get rid of the first radical, so a little bit of work here. All right, so that takes care of that. So x minus 1 equal to, now again, use that formula. Here's my a, there's my b. Okay, a little bit more complicated. A squared is what? 3 squared is 9. All right, what's a times b? A times b is 3. Here, let me do the AB term here. That's going to be what? 3 outside, radical x plus 2 inside, right? But I have to double this 3, right? So 2AB becomes doubling the 3. I get 6 radical x plus 2 here, if you will. So again, perfect square formula, right? So 9 plus what? 6 radical x plus 2. And then b squared is simply getting rid of this radical here. So plus x plus 2, because when you square this radical here, it gets rid of it. Okay? So that's what we have. But we have to combine like terms now, right? So it's a little bit more complicated calculation, but the theme is the same. Okay, so let's isolate this remaining radical, but first combine like terms. 9 plus 2 is what? 11, right? So 11 there, right? Plus 6 radical x plus 2 plus x. Again, let's isolate this remaining radical. So I'll subtract 11 here on both sides and subtract x on both sides. All right, so that gets rid of that, and that 11 there on the right. On the left, cancels x again, which is good, and that's going to be negative 12. That's 2 there. Sorry about that. Negative 12 equal to what? 6 radical x plus 2. All right. Let's divide both sides by 6 again, because 12 is divisible by 6. So we're going to get negative 2 equal to square root of x plus 2. All right? But look what's happening here. You have a square root of a number equal to a negative number. Is that possible? Well, as it turns out, there's no number that I can think of for x. If I plug it in here and work it out with x plus 2, and I take the square root of it, that I can get a negative number out of this. This is impossible. This equation is never true, because I cannot get an x that will that I can take the square root of it with x plus 2 to get a negative number out of that, because the square root of a number is either 0 or positive, right? So therefore, there's actually no solution here to this equation. No solution, if you will, right? So so that's our conclusion here. No solution for this particular, oops, sorry for the sketch pad here. No solution here. All right. Now, suppose we did go through and solve this, right? Let's say you try to square both sides. Let me just copy it again. Let's say you didn't know about this fact that the square root of something can't be negative, right? Then let's say you go through and try to solve it, right? It'll be fine. It's just not going to check out, because look what happens here. If I square both sides, I put a parenthesis there. That's positive 4, negative 2 squared. And again, that gets rid of the square root there. So x plus 2, if I subtract the 2 over, all right, then, oops, sketch pad, come on. All right, sorry about that, guys. All right, so you get 2 is equal to x. So our x is equal to 2. That's supposed to be an x right there. All right. So anyways, so we get x is equal to 2, bottom line here, right? So let's plug it back in. If I plug 2 back in, what happens? 2 minus 1. Here, we can check it. Let me show the work here. So we got x equal to 2, right? So let me show you that's not going to work out. If I plug 2 in, what happens? Square root of 2 minus 1 minus the square root of 2 plus 2. Okay, now I plug it in 2 for x, right? So that's going to be square root of 1 minus the square root of 4. So 1 minus 2 in this case, right? Which is negative 1, which is not going to be the right side, which should be 3, right? So, all right. So that's why, again, same conclusion, and no solution in that case. All right. So again, key is what? Completely isolate the radical, the square root in this case, right? If it's equal to a negative number, then there's no solution. Now, keep in mind, this is only true if the root index is even. All right. If the root index, remember from previous homework, that if for radical functions, if the root index is even, we have to make sure the inside is what? Greater than or equal to 0. But if the root index is odd, then it could be anything inside. It could be positive or negative, right? So it could be all real numbers in that case, right? So keep that in mind. So for square root, then you can see that if you isolate this square root or the fourth root or any even number root index, it cannot be a negative number. Otherwise, there will be no solution. All right. So let's go ahead and take a look at the problems that I want you to try and post into Blackboard here. So hopefully you got a gist of the concepts of solving these equations with radicals here, right? Isolate them, take them to a certain power to get rid of them, and finish solving the remaining equation is really the theme here. All right? Let me go and clear out the screen, give you the 3 problems I want you to post the solutions to into Blackboard. All right, let me go and clear out the screen. All right, so number 1, I want you to solve this equation. So solve the following 3 equations here. All right, so basically solve. All right, so let's go and solve. The first one is going to be a cube root of 2x plus 5. All right, plus 7 is equal to 4. All right, so solve this cube root equation. That's 4 there. Sorry about that. Sketchpad is starting to act up on me. So let me go and quickly get through this here. The second equation is going to be x plus 3 square root of x minus 2 equal to 12. Okay, so solve this equation here. That's 12 right here. All right, and number 3, let's take a look at 2 radicals here for you. So radical x plus 1 minus the square root radical x minus 15. All right, equal to 2. All right, so let's go and solve these 3 equations with the techniques mentioned here and post them into Blackboard. All right, so until next time then.